Okay, I hope my screen is visible. Every day I need to confirm this. Type yes in the chat box. Good. Okay, so let us get it started. And before that, let's do a small recap. So I have introduced about the queue interface in Java, and we have understood the internal working of priority queue in the yesterday session, right? So priority queue was understood in the yesterday's class. So today we will understand a few more points on top of the priority queue. So let me introduce, not introduce, let me take that collection diagram. Okay, right? See, now we got to know what is queue. Okay, now we got to know what is queue. Queue is an interface, and we have also understood few points about the priority queue. So we have understood something, it's some internal things about the priority queue. Today I will introduce a few more methods on top of priority queue, and we will see that method, and we will also complete the deck and array deck, right? So let's get it started quickly. So let me write a small program here. So I want to add few numbers by using queue interface. So let me take queue, and since I want to add numbers, I am taking the generic type as what? Integer, right? So what I want to add some numbers, right? So and since we cannot create an object for an interface, so I am using the implementation class, which is priority queue. Now focus here. So I'm adding few numbers. Numbers dot add. So let me take some random numbers. First numbers, let it be 10, right? I want to add at least 7 numbers. Okay, first number is going to be 10, second number is going to be something like 3, third number is going to be something like 1, and fourth number is going to be 20, and fifth number is going to be something like 15, and sixth number is going to be something like let it be 7, and the last number is going to be something like -1. Okay, these are my numbers that I have added. So when I try to print this reference variable, so we know already the output is not going to be in the form of sorted order or the insertion order. So the output will be displayed according to the internal data structure of priority queue. We have discussed these things already. Okay, if I run this code, I will get an output in an order. Okay, so this order is achieved because of the elements are adjusted in such a way that internally it is following what concept? Internally it is following the min priority concept. We have discussed these things yesterday in depth, right? Now what I want you to understand is, okay, again let me quickly repeat this once again. So this is the order that the elements are added. So 10 followed by 3 followed by 1 and followed by 20, and we have 15, we have 7, and we have -1. Okay, so let me take this really quick. Okay, these are my elements. Okay, these are our elements. So this is the order of our elements. So we have added 7 elements. Okay, 10, 3, 1, 20, 7, 15, 7, and 1. Right? The moment you add the first element, 10, okay, the 10 is going to get placed in the root node. Right? So no doubts, no more doubts about this. Okay? 10 will get occupied in the root node. Right? The second element is 3. Okay? So the root, the nodes will be created from left to right in the form of binary tree. So any node can have maximum of 2 children. Right? What is the second element I want to add, guys? So we are trying to add, okay, we have already added 10, and now I want to add something like 3 I want to add. So 3 will be added in the next position, which is this one, right? So after the element is added, a comparison will be added between, comparison will happen between the parent and the child. Okay, this is the parent and this is the child. The comparison will happen. Okay, if the element of child is lesser than the element of parent, shifting will happen. Okay, let me repeat. The element of child is lesser than element of the parent, shifting will happen. Okay, the child element will will occupy the parent position, the parent element will come to the child position. This is what we have seen. We have seen these things yesterday. So give me a minute, guys. Give me a minute. I am getting a call. Hello. அவர் வந்துட்டார். அவர் நம்பர் ஒன்று அனுப்புறாரு. Okay, sorry about that. So we have added only one element here. So second element is added. So the second element is the number, the numerical number 3. Since this is lesser than the parent element that is placed in the parent, so shifting has to done. This will occupy, this will go up, and this will come here. Okay, so these things are understood. Okay, now what is the third element? Third element, we are trying to add the value 1, right? So a node will be created according to the binary tree. Node will be created, and you are trying to add the element 1 in the created node. After adding this, again the comparison will happen between the parent and the child. A child element is lesser than the element that is placed inside the parent node. I mean, that is placed inside the parent. So shifting will happen. Okay, you add elements in such a way in the binary tree from the left to right direction, and the elements get adjusted accordingly by using the concept of mean priority, right? So 3 elements are successfully added now so far, and next element is 20. So a root node will be created, right, from left to right, and 20 will be placed here, isn't it? Definitely 20 will has to get placed here, right? And this 20 will be comparing the value of the parent node, which is 10. So this is greater. So if it is greater, if the child value is greater, no shifting. Only if it is lesser, shifting will occur. So this will remain unchanged, right? Now the next element is 15, isn't it? So 15, to add a 15, you need to create a node will be created, and 15, the value 15 will be added just below here, and a comparison will happen. There will be no change because this value is greater than the parent value, right? And again the next value is what? This 7. Okay, 7, and 7 will be added here, isn't it? 7 will be added here, and a comparison will happen. Since the value, the child value is greater than the parent value, now shifting will occur. So this will remain unchanged. Okay, what is the last value that we have? The last value that we have is what? The -1, right? And the moment the -1 is added, now you focus, -1 has just been added, right? And a comparison will happen. So this -1 is definitely lesser than the parent value, right? -1 is lesser than the 3, is lesser than 3. So shifting will occur. So this is going to get here, and this is going to come here, right? Again it will not settle just like that. Again this value will be compared with its parent, with this anchor store. Okay, since -1 is lesser than 1, so this will go up and this will come down, right? Good. So all the elements are added. So this is how the elements gets added in a binary tree. So this binary tree is called as what? The complete binary tree. Complete binary tree. It is going to use a complete binary tree to store the inserted values. So these things are discussed already in brief in the yesterday's class. Complete binary tree. Okay, after the values are filled in the complete binary tree, how these values will be retrieved? The values will be retrieved from the left to right direction, starting from the root node. Let me repeat, left to right direction starting from the root node. So this is the root node. First minus 1 will be retrieved. Okay, minus 1 is going to get retrieved, right? Followed by, okay, it is going to see the second branch, second level, and left to right. 10 will be retrieved, then 1 will be retrieved, right? 10 followed by 1. Then we have what? The third level from left to right. 20 will be retrieved, 15 will be retrieved, 7 and 3. So this is the order of the values that is going to get retrieved when you are using the priority queue. You add elements in one order, but the retrieval happens in this order. This is called the min priority order. Are we getting the same order? Don't you think so? We copy this and paste it here. So is it matching? Minus 1, 10, 1, 20, 15, 7, 3. So this is why we are getting this order. But why it is necessary to get elements in this order, that we will understand. So before even understanding that, I will introduce you few more methods here. Please stay focused. I want to introduce you few more methods. So for the time being, let me remove this. So we got to know the procedure of insertion. Let me remove also this. Okay, let me remove this also. It is not required. I want to minimize this, and I also want to minimize this. Okay, let me minimize this also. Okay, now let me introduce few more methods. Now I want to introduce a method in the priority queue. In the queue I want to introduce a method. So the method name is, so there is a method called a very famous method is system.out.println numbers.offer method. The name of the method itself is offer method. It is offering you something. What kind of things that you can offer, what kind of parameter that you can offer. Okay, you can offer an object or you can offer an element. For example, let us say that I am offering a element, let's say the element like minus 2 I want to offer. Okay, so this instruction is going to do, it is going to do so many things behind the scenes. Okay, I'm going to add something like minus 2. Offering means you're offering an element. What element you're trying to offer? You're offering a element by the name of minus 2. Okay, you want to offer this element. Okay, the moment you offer this element, this minus 2 will get a position from the left to right. See, this is the root node. This root node has 2 branches. These 2 branches are filled. And again, the children of these 2 branches are also filled. Right? And again, if you want to get a new node, the position of the new node will be from left to right. So this is the position, this is the possible position of the new node. So you are offering an element which is minus 2. So you want to offer minus 2. So minus 2 will be added in the root node that starts from the left direction, extreme left direction. Okay, as soon as you add this element, lot of things happen behind the scenes. As soon as this element is added, internally this element has to get adjusted in such a way that it is following the min priority approach. What is it? Min priority approach. Okay, so you have added an element. The element is minus 2. This minus 2 will get compared with this parent. Okay, the parent element is what? Greater, and the child element is lesser. When that is the case, shifting should happen. Okay, this element will come bottom and this element will go here. Okay, shifting is happen, no issues. And again, this will not remain calm. Again, it keeps checking its anchor star. This minus 2 will keep checking its parent. Again, this minus 2 is lesser than 10. Yes or no? Okay, so shifting will happen. Okay, I'm sorry. 10 will come here, minus 2 will take the position here, right? And 10 is going to get this position. So again, this is not going to stay calm. Okay, this minus 2 is still lesser than the parent, minus 1, isn't it? Which is lesser, minus 2 is lesser. When the child is having the lesser value, what is that? What are the things that is going to happen internally? Shifting will happen. Not shifting, swapping will happen. Swapping will happen. I'm sorry about using the word shifting. It's swapping. Okay, this will go here and this will come here. Okay, now these are the things that are going to happen behind the scenes the moment you use the method called offer method. Okay, you use the offer method means an element will be added in such a way that it is going to follow min priority. Okay, you add one element, this element will be adjusted in such a way that it is following the min priority. So now after adding this, when you try to print the numbers again, when you try to print the reference variable, okay, so I want to print the numbers once again. I want to print the numbers once again. So if I print this number, if you observe the order is -2, -1. So don't you think that we are getting the same thing? See, this is the answer. See, first -2 followed by -1, 1. We have 10, we have 15, we have 7, and we have 3, and we have 20. Traversal will happen in such a way that, okay, retrieval will happen in such a way that it will start from the root node and it follows the left to right direction. Root node done. Left to right direction. -1 will be retrieved, 1 will also be retrieved, 10, 15, 7, 3, 2. So this is the direction. Please don't forget this. Okay, this will start retrieving from left to right, left to right, left to right. So we have fetched the values. Okay, the offer method will do so many things behind the scenes, right? So if you are trying to offer an element something like a bigger number, okay, so -2 has done a lot of changes behind the scenes. A lot of changes has happened because of -2. But after adding -2, I also want to offer another element something like a bigger number. Okay, numbers dot offer. So this time I want to add something like a bigger number 1000. Okay, let me copy this piece of code. Okay, and let me paste it here. So I want to add 1000, and again 1000 will be added in the here because every node will have 2 branches, right? So over here the 1000 will be added, right? After you add 1000, okay, this 1000 is a very large number among all these, so now there will be no swapping. And again, if you try to print this system.out.println once again numbers, so this 1000 will be placed wherever it is, because there will not be any adjustments behind the scenes. No adjustments we can see because it is a larger number, it will remain there only, right? So 1000 will come here. So the idea is offer method is used to add an element, but depends upon the element or depends upon the value. This value will get adjusted in such a way that it is going to follow min priority concept, right? So let me introduce one more method here. Okay, so I want to remove this example, so we do not want to worry about this. We got to know what is offer method, right? So let me remove all this. So I want to keep the example very simple. Okay, this is our actual example. So we got to know what is the purpose of offer method. Let me remove this. Right, this is our actual example. So these are the elements that we are getting from the actual example. Okay, now there is another method called system. This is very important method. Okay, focus here. System.out.println. So we have a method called poll method. Numbers dot poll method. Okay. What this method is going to do, I will explain. Okay, poll method is used to remove an element. Okay, this method is used to remove an element. Okay, how the element will be removed, that is the question, right? For example, like when you go to a market, when you go to a fruit vegetable market or fruit market, so sometimes you see the apples are arranged in the order of a kind of pyramid pattern. So this is how the apples are arranged. So In the top, they place the shiny apple or they place the good apple, and followed by two apples in the bottom, followed by four apples below those two apples. So this is how the apples are arranged. Okay. Top apple will always be shiny because they should be attractive. So they place the shiny apple or they place the good apple, and they place the best apple in the top of the pyramid or in the top of the heap, right? And you cannot even guess the quality of the bottom apples. You don't know the quality of bottom, but you can visualize the quality of the top apple. Apple would always be shiny, right? So when you are purchasing a pack of apples, a pyramid of apples or a piece of apples, so what is going to do? What the fruit seller is going to do? He takes a cover and he is going to fill the apple in such a way that the element will be removed from the top. First apple will be removed and this apple will be placed inside the cover, followed by these two apples, followed by these four apples. Always top apple will be removed, right? You cannot touch the bottom apple. If you try to remove the bottom apple, the structure will collapse, right? If you try to remove this, all the apples will collapse, right? So they don't do that. They remove the top apple, then followed by these two apples, then at last they will remove this last four apples. Like this is how it works, right? Likewise, the moment you use the method called the pole method, right? The root node element will be removed. Let me repeat. This pole method will work in such a way that the root node element, what is the element in the root node? -1 will be removed. This element will be removed. This topmost root node, the value inside the rootmost element will be removed. Right? So how this is going to work, I will explain it. Okay. So I have just used what? In our example, I have just used a pole method. Now focus here. Okay. I have just used a method called pole method. The moment you use this method, the topmost element, the most prioritized element, which is -1. -1 will be removed and returned. -1 will be removed and it will be returned. It will be returned to you. Okay. So where is the proof that -1 is getting removed? If I run this, you will see -1. You will see -1. So -1 is getting removed, right? And after removing this, what happens? This place is completely empty, right? This empty place will be occupied by the extreme right element of the complete binary tree. Let me repeat. This empty space will be occupied by the extreme right element of the complete binary tree. So what is the extreme right element? This is extreme left. This is extreme right. This 3 will going to occupy its position. This 3 will occupy which position? Will occupy the top position, right? And as soon as the position is completely occupied, this node will be removed. This node is empty, isn't it? Okay, this node is going to be what? This node is going to be removed. These are the internal things. You really don't need to worry about this, but understanding what is happening behind the scenes is very, very important. So that's the reason why I'm stressing this topic much. Okay, so this node will be empty. This will be deleted. Okay. So after having all this, now the adjustment will happen. Now what happens? It will trigger an adjustment. The 3 is added here. Okay, this 3 will compare itself with its children. What are the children it has? 10 it has, 1 it has. Right? Which one is the smallest one? 1 is the smallest one. This 1 will be compared with this 3. Okay, if it is lesser, okay, if it is lesser, if the children is lesser than the parent, swapping should occur. Same concept. Okay, this 3 will come here. Okay. 3 will come here and this 1 will go in. Swapping will occur. Right? So after this swapping, and if you see, again this will get compared with this child because it is disturbed, right? Adjustment is disturbing the complete binary tree. So this will be comparing with the children. The value inside the child node is 7 and the value inside the parent node is 3. So there will be no changing, right? So if I try to, so these are the changes that will happen behind the scenes. These changes will trigger the moment you use the poll method. Okay, now what you're trying to do, again, if you try to system.out.println numbers, right, after using the poll method, and again, if you try to print the reference variable, now you see the values 1, 10, 3, 20, 15, 7 we have, right? Is it matching with the complete binary tree? Right, it is matching, because if you look at the order here, okay, 1 left to right is 1, we have 10, we have 3, and we have 10 here, 3 here, and we have 20, 15, 7, right? So let me remove this. Okay, now you see, now focus here. Okay, we have used poll method once, so 1 has been removed. I want to use the poll method for the second time. See the internal things. See the internal things. I want to use what? I want to use the poll method for the second time. Let me remove all this, which is not required. Okay, poll method has been used once. I am using the poll method for the second time. Right? When I use this for the second time, so this is the adjusted binary tree. So I am using poll method for the second time. Right? Let me copy this and let me paste it in the paint script. Okay, second time I am using. When I use the second time, poll method is going to remove the topmost root element. So now 1 will be removed. Right? 1 will be removed, and this position will be occupied by the extreme right element. So 7 is going to occupy the removed space. Okay, this will be shifted here. 7 will occupy this place, and this node will also be deleted. Okay, so as soon as the 7 is shifted here, now it will try to adjust the complete binary tree. So this 7, the element 7 that is recently added, will check with its children. Okay, so when you compare these two nodes, 3 is lesser, and when you compare this 3 with the parent, what is it? Should remove this, guys. 1 minute. Okay, adjustment will happen now. Okay, 7 will be compared with this 2. Among these two root nodes, 3 is smaller. Okay, this 3 will be compared with 7. 3 is lesser, so swapping will happen. So 3 will come here, and 7 will come here. 7 will come here, and 3 will come here. Then after this, there will be no more shifting. So 1 is removed. 1 is removed, and if you try to print the reference variable numbers, okay, so the 1 is removed, and remaining values are 10, 3, 10, 7, 20, 15. Look at the order: 3, 10, 7, 20, 15. Okay, let me use the poll method for the third time, then you will understand the importance of the poll method. By looking at the values that we are retrieving, you will get a pattern here. Try to understand that pattern. You will get to know what are the benefits that you are going to get by using the poll method. Okay, what I want to do here, instead of printing numbers, I want to use the poll method for the third time. I am using it for the third time. Focus here. Okay, third time I am using the poll method. Okay, the moment whenever you use the poll method, the topmost element will be removed, isn't it? The poll method is being used for the third time. Right? So topmost element will be removed and returned. It will be returned. Will be returned here, right? And this position will be occupied by this element, the rightmost element. Okay, as soon as this element is filled, I mean the node is filled, right? This node will be removed, right? And the adjustment will happen now. Okay, so these two, when you comparing this, compare the two children. This is smaller, 7 is smaller, and 7 is also smaller than its parent. Okay, shifting will occur, adjustment will happen, swapping will occur. Okay, now 15 will come here, 7 will go here, right? 15 is going to come where? It's going to come here. After this, no more adjustment, and now let me print the reference variable numbers. So numbers. Okay, if I print, so we will remain with 7, 10, 15, 20. Look at the order. We have 7, 10, 15, 20. So order is matching. Okay, now if you observe the pattern, okay, we are removing the least element in the beginning, followed by the greater element, followed by the greatest element. Means there is a sequence of, if you observe this pattern, it is what? Elements are getting removed in the ascending order from the smallest element to the largest element. Right? It is going to follow the ascending order only. If you remove element, elements are getting removed in the ascending order. So we are able to sort the element by using which method? By using pole method. Are you getting this? Let me do the pole method for the fourth time. Okay, if I do the pole method for the fourth time, again you will get an element in the sorted order. Okay, pole method for the fourth time, and topmost element. Now this time 7 will be removed. 7 will be removed, and 20 is going to occupy this vacant position. 20 will come here, and this has to be deleted. Right, and this 20 will be compared with this two anchor stars. Okay, this is smaller. Okay, then 10 will be swapped with this 20. Smaller number will get a chance to be swapped. Smaller number will come here, and larger one will be pushed or adjusted to the child node. Okay, so remaining values are 10, 20, 15. Are we getting the same output? 10, 20, 15. So look at this. Least element is removed first, followed by the greatest element, followed by the more greatest element, most greatest element. Okay, ascending order pattern is there. Okay, what I can do, I can use a pole method in such a way that I will use an iterator. Okay, I want to use an iterator. So I'm taking a variable here, integer size equal to, I want to find the size of numbers dot size. So let me, instead of size, let me keep a variable name as here. Okay, I'm running a for loop starting with integer I equal to 0. I is lesser than a, I plus plus. Okay, I'm using the system.outer print statement. Directly I'm using what? I'm using numbers dot pole method. Okay, I want to give a space. If you observe the pattern, so I keep using the pole method repeatedly. Don't you think that the output is in the form of the ascending order, minus 1, 1, 3, 7, 10 followed by 15, and we have 20. Right, least element is removed first. So this is some kind of a beneficial for us, right? You want to find the ascending order, you can use the pole method in the for loop so that all the elements are returned in the ascending order. Or you can also say that the least element will always retrieve first. The least element will always, the smallest element will always be retrieved first. So this is the importance of what? This is the importance of the pole method. So we have discussed two methods so far. What is the first method we have discussed? We have discussed the offer method, and second method is pole method. Right? So let us go back to the actual diagram. So I don't like this diagram, so I want to, this is our actual diagram, isn't it? Okay, let me remove these apples also, not necessary. Right? So let us understand the importance of another method. We have a method called system.out.println numbers. We have a method called peak method. Numbers dot peak. Okay, so see the diagram and you will understand what is a peak. Peak method is -1. Peak method is returning a value called -1. What does it really mean? It is going to remove the topmost element of the pyramid. Right? In our binary tree, like just have a look at the binary tree. So if you say peak, it is going to return the topmost element. What is the topmost element in this complete binary tree? So this is the topmost element. The root element will be written. The root node element will be written -1. Right? It will not be removed, it will be written. Right? Now if you see, there is another method called as the remove method. Okay, let me remove this. So this remove method and this pole method are one and the same. They both are same. They both are going to do the same thing. But there is a small difference between the remove method and the pole method. Okay, remove method and the pole method both are going to remove the topmost element. Okay, topmost element will be removed. Both are going to do the same thing. But you cannot use the remove method on the empty priority queue. When I say empty priority queue, if you are not adding any elements, if you are not adding any elements, and if you are trying to use the pole method, okay, this pole method is going to give you the null value. But if you are trying to use the remove method on top of the empty priority queue, right, it is going to give you an exception. That is the only key difference. That's it. But operation wise, both are going to do the same thing. The purpose of pole method and the purpose of remove method, they does the same thing. They're going to remove the topmost element of the root, or the base node, the root node. It will remove the root node element. But if you use the remove method on top of the empty priority queue, you will get an exception, but you don't get the exception when you use the pole method. This is the only one difference. That's it. Right? So how many methods we have discussed so far? Methods of queue. Okay. What are the methods that I have introduced? I have introduced the offer method. Offer method is going to accept an element or object, or I can say that element E, right, and it is going to return something. No, it is not going to return anything. I think return type is it is going to return something. Yes. Second one is, we have discussed about the offer method. We have discussed about pole method. The third method is we have discussed about peak method. The fourth method is we have discussed about what? The last method, remove method. Okay. What is the difference between peak and remove method? I mean, not peak and pole and remove method. Pole method versus remove method. Okay. Pole method does not throw an exception when it is used on the empty priority queue variable. However, remove method throws an exception when it is used on the empty priority variable. As simple as that. This is the only difference. You may get this question. This is a very important question. So we have completely discussed about the methods of priority queue and internal only of methods of queue, internal working of priority queue also been discussed, and something about the queue interface also discussed. Right? And now let us try to understand some theory about what priority queue. Since priority queue is the child class of queue interface, so everything is applied, all these 10 points is applicable for priority queue also. Right? Apart from this 10 10 value point, 10 points, you can add a 11 point, like its internal capacity is 11. These are additional points. 12th one is it is non-synchronized in nature. It is non-synchronized in nature. 13th point is its performance is high. 14th point is it is not thread safe. 15th point is it can't be used in the multi-threaded environment. And these are the important points that you can note for the priority queue. The same points is applicable for the priority queue. The points that has been used in the queue, the same points are applicable for the priority queue. Right? And now the next topic is I want to introduce what? About array Deque. Okay, so priority queue has been discussed successfully. Now we will try to understand about this Deque. We will try to understand what is Deque, followed by array Deque. Right? So what is Deque? It is not DQ, it is pronounced as Deque. It is not DQ, it is pronounced as Deque. Everyone will, most of them, they pronounce it as DQ, but it's not DQ. It is called as Deque. Okay, the first point is TCA. So by looking at this diagram, I can write one point. It is the child interface to queue interface. First point, child interface to the queue interface. Right? So queue is an interface. So Deque is also an interface. But which one is child? Which one is parent? Queue is the parent and Deque is the child. Right. So let me try to explain you about the internal working of the Deque. So before even understanding about the internal working, you can add elements for the Deque in the both the sides. Okay, before even understanding that, let me try to show you a small diagram. So it is just like standing in a line, guys. Very simple. It's just like standing in a line. If you are adding an elements, you want to add some elements. Okay, let us imagine that this is a queue. Okay, I want to add elements. Okay, firstly I want to add the element 1, 2, 3, 4, 5, 6, 7. So this is the order of my element. So it completely follows the FIFO algorithm. When I say FIFO, first in first out. Okay, if you add 1 will enter into the queue, right? And the second Q2 will enter in the queue, and 3 will end followed by 3. So it is going to maintain the insertion order, because why it is going to maintain insertion order? It is going to follow the FIFO algorithm. What is FIFO algorithm? FIFO is an acronym of first in first out. The element that is getting in first will be the same element is going to come out first. So if the elements are added in this way, so this is a kind of what algorithm? FIFO algorithm, right? And the process of adding is called as what? The NQ. And the process of removing an element is called as what? The DQ. DQ. Right? And if you try to print the elements inside the queue, all the elements are printed accordingly. The element that is getting inside first will be the element will be coming out first. Okay, the second element will be coming here. The third element will be coming here. Fourth element will be coming here. Fifth element will be coming here. Sixth element will be coming here. Seventh element will be coming here. So unlike in the priority queue is going to follow a complete binary tree structure, and it is going to follow the min priority algorithm. But this is not like that. It is following completely FIFO algorithm, first in first out. So where is the proof? Okay, let me take the interface as queue here, Deque here. So the child, the implementation class is what? Array. Right? I want to add some numbers. Numbers dot add. I want to add 10, followed by. Let us take the same numbers if you want. Firstly, I want to add 1. Secondly, I want to add 7, something like 7. and thirdly I want to add, let it be 2, 3, 4, 5, 6, 7. I want to print the numbers. And if you observe the output is going to be in the same order 1, 2, 3, 4, 5, 6, 7. But if you use a priority queue here, priority queue is going to print in such a way that it is following the minimum, min algorithm, min priority algorithm inside behind the scenes. If you don't understand that, you can repeat the extended session. Right? So this is how the queue will work. It is going to follow the actual FIFO algorithm, first in first out algorithm. Okay, here we have a very famous methods here. Let me introduce few methods today. For adding elements, we have a method like the add first element, add first method. Now focus here, numbers dot add first. I want to add something like 1000. Okay, so when you use the add first element, okay, the return type is void. That's what it's giving us. If you use the add first element, after using this method, after using this add first method, you are adding 1000. So look at the changes. This 1000 is getting added in the first. If you want to observe this in the diagram, okay, this is how the queue was. Okay, so this arrow should not be here. Which arrow should be? Okay, this is how the queue was. Right? So what I have added just now, I have added an element 1000 by using add first method. Okay, so I want to add 1000 by using add first method. Okay, this add first method will be added, is going to occupy the first position. This just like when you are giving a darshan in Tirupati temple or somewhere, you will be standing in the queue for the long time, but there are VIPs, isn't it? So VIPs, even no matter what, even though if you spend a lot of time standing in the queue, so they get top priority. So that is an exceptional case, isn't it? They get chance without any waiting time, without even have to wait. So they will be given priority. So same like that, right? And if you print it, first 1000 will be printed. Right? So this is the one way of inserting method by using add first element, and there is another thing, add last. If you have a queue already, and if you want to add the value 1000 by using add last method, this time this 1000 will be added in the last. Right? Visualization. Okay, this time previously it was here, now it will be here. It is very common. The last element has to be added last. Common people, okay, if the common people is trying to occupy the queue, they have to occupy the last space, but it is not the same rule is not applied for the VIPs, same like that, right? And we have another method called in offer first element method is there, offer last method is element, offer last method is there. This is add first and last, add last. We have the method called offer first. Okay, this offer first is going to tell something. It is going to communicate with the user. Okay, it is going to say if the element is added successfully, it will say true. It is just like, guys, it is very same. Okay, so offer first is going to work in such a way that this element will be added first. As soon as it is added successfully, it is going to give you a message. What? It is going to return a boolean value, which is called as, if it is added successfully, you will get the value as what? The true. True will be returned. True will be returned to you. You add the value, true will be returned to you. Right? Likewise, you have a method called offer, I think offer last method. When you do this, it is going to, the element is going to add it in the last line of the queue. The last position of the queue, right? As soon as it is added successfully, it will return true. The return type is boolean, as simple as that, right? So where is the proof for this? See, true. The 1000 is has got added in the last, right? This is how the elements are added, and there are some methods to remove the element. Okay, to remove the elements, we have methods like remove first. Okay, so let us understand this. Okay, the first element will be removed. Let me, this is not the actual code. Let me remove this too. It is not required. Okay, again we are starting from the beginning, and where is it? Yeah, remove first. We are using a method called remove first method. So all the numbers are added. So numbers are printed 1 2 3 4 5 6 7. So what I want to do, I want to remove the first element. Okay, one will be removed and return, and you will be getting the remaining values, right? So this is the visualization. When you use remove first method, the first element in the queue will be removed, and the remaining elements will be there as it is, right? Likewise, you have a method called remove last method is there. Remove first means first element, remove last means last element. Okay, what is the last element? 7 has to be removed. Okay, right? Likewise, we have the two more methods called poll first method is there, right? Poll first method is going to remove the first element, and the poll last method is there. It is going to remove the last element. So what is the difference between remove first and the poll first? So that could be the question. Okay, now if you are trying to remove the element on the empty deck by using the poll last, you will get null. Okay, if you do the same thing by using remove last, right? So remove last is going to give you an exception. That is the only difference. When you use poll will not give any exception, but when you use remove will give some exception. That is the main difference between poll versus remove. You can either use first or last. If poll is not going to give you any exception, you can use it on the empty deck. But remove method, you cannot use it on the empty deck because it will give you an exception. You should take care of this exception, right? So like this, there are there are 4 more methods for the retrieving of for the elements retrieval. So what are the four more methods? So let us go back to the same program. Okay. So for retrieving the elements, we have get first. Okay. Get first is going to give you the first element, and the remaining elements will not be touched. Elements will not be removed. It will identify the first element. Okay, it will identify the first element. First element is 1. 1 will be returned. Okay, and if you look at the variable, it is going to be same. No elements will be affected. It's just retrieving the value and giving it to you, right? Likewise, we have a few more methods called get last method is there. Get first like that. Get last method is there. Okay. When you use get last method, it's going to give you the last element of the array deck. Okay, what is the last element? 7 is the last element, isn't it? 7 will be given. It will not be touched. Everything is going to be remain same. Likewise, we have peak first and peak last. Okay, the purpose is same, but there is an advantage with peak first. Peak first element will be given to you. Okay, peak last element will be given to you. Okay, then what is the difference between the get first and the peak first, or get last and the peak last? Okay, if you use peak last on the empty deck, there will be no issues, null will be the output. But if you use the get last in the empty deck, you will get an exception. That's it. Okay, what are the methods that we have discussed? I will give you the notes in the description, and I will make it in the description. I will make it available in the description. But what are the methods that you have discussed? You will understand that. Adding elements, for adding elements, we have add first, right? And it is going to accept an element. Okay, so add first we have add last we have, right? So we also have offer first, right? And we also have what, offer last. Okay, so this is for adding. For removing, we have another 4 methods. Remove first, remove last, we have poll first and poll last. Okay, so likewise we have 4 methods for retrieving elements. Get first, get last, and we have peek first and peek last. And we have peek. Okay, so that's all about this. So